Alright, so in the last presentation we went over a little bit of a conceptual overview of Euler-Bernoulli beam theory. And now what we're going to do is we're going to go ahead and start applying it to the barbecue grill. We're going to start looking specifically at how the barbecue grill is designed to make use of this kind of theory. And in the case of the barbecue grill, what you'll find is that a lot of the parts, like I mentioned in the second presentation, are actually stiffness limited, not so much strength limited. You're not usually worried about a part of your barbecue grill breaking off. You're more worried about the grill deflecting when you put a big pot of beans on one of the shelves or something like this. So let's go ahead and get started. And one thing I should mention, the things I'm going to talk about here, the main point of them is to give you some idea of how you can start to take a structure and make it more stiff. Or you could conversely even potentially make something less stiff if you wanted to, as long as you understand the principles. But we're not so much worried about quantifying what the stiffness is. Just these kinds of things will give you some ideas on how to make your structures more stiff. Now, if you look throughout the barbecue grill, in these two portions right here, you have these very thin, lightweight members that hold the legs front to back together. And these are actually thin sheet metal constructions that have that same channel shape as in the beam I talked about in the last presentation. And you can see that going on here and here. So this is an example of getting a high area moment of inertia, but for a very small amount of material and being very lightweight. If you even look at the handle on the barbecue grill, this is just some plastic. It's a plastic handle to open the lid. So the idea is they want to use as little plastic as possible to keep costs down. But they still need the handle to be sturdy and stiff so people feel confident opening the lid of their grill. So if you look at it, this thing actually has kind of a U shape built into it. And that U shape, it effectively gives this handle a relatively high area moment of inertia. And so it's stiff, but it uses very little plastic to accomplish that. Now, another area to look at is this beam that holds the propane tank up. This is arguably one of the most highly loaded portions of the barbecue grill. And if you look at it, at least on mine, it's a similar U-channel design to what you'd see over here, but these kind of upper and lower flanges are deeper than what you see over here. And the reason is the deeper those things are, the more stiff your structure is going to become. And once again, you add just a relatively small amount of additional material, but you gain quite a bit more stiffness. And you need that here because this propane tank is relatively heavy. These members over here aren't loaded very much, so you can get away with less material over there. Now, let's go ahead and look at the shelf. This is an interesting example of applying these kinds of principles. If you look, this is the plastic shelf that's on the side of the barbecue grill. This is kind of the bottom view of the shelf. And what you notice if you look at it, this thing has stringers running front to back and side to side. Okay, and what those stringers are for is, once again, they can add a little bit of stringer material down there at the bottom of this plastic shelf, and they can significantly increase the bending stiffness of this shelf for very little additional material and cost. They're effectively adding a significant amount of thickness to this shelf just by adding a little stringer. And you know, if you were to go and put your pot of baked beans or whatever on top of this thing, this shelf is going to stay sturdy. It's not going to sag under the weight of the beans because of these stringers. It's also interesting to point out, if you look, there's also these two stringers at plus minus 45 degrees. And what they do is they essentially increase the torsional stiffness of the structure. So if you were to put this pot of baked beans kind of off-center on this shelf would tend to want to twist. And these stringers, the plus minus 45, they help resist the tendency of the shelf to twist. And if you want to look in other places, if you look at something like a cast drill press table or things of that nature, you'll oftentimes see stringer-like construction like this. So that's another example where you can see this kind of thing going on. So next, what I want to do is look at the whole, basically the main body of the barbecue grill. So this is the lid, and if you look at it, the lid itself is kind of given a U-shape channel design, similar to what we had here. And so that's part of the reason the lid in and of itself is fairly stiff, because it has this U-shape, high area moment of inertia shape to it. Now, you should also notice though, there's a sheet of metal here on each end. And what those sheets of metal effectively do is they act as what we call shear panels. So they keep this side of the lid from wanting to separate any further from this side of the lid. And if these shear panels weren't there, this lid would just be kind of really floppy and it would just sag over. So that's something that's kind of important to notice. When you put these kind of panels here, you significantly increase the stiffness to basically torsion as well as the bending stiffness. So you'll see the same thing here on the bottom part of the grill as well. So the concepts I've discussed so far are things that most anybody with an engineering background who's taken solid mechanics will probably easily recognize. In the next portion of the presentation, I'm going to start talking about things that you probably wouldn't recognize so easily, and this is kind of where I think the real meat of this presentation comes in. So I hope you'll watch the next video. Thank you.